Page 1, this stuff is really pretty easy. We are plotting polar coordinates. This right here is your radius. That right there is your radian. Here's what I recommend doing. I recommend first, let's identify where is pi over 2. Pi over 2 is here. So then what I would do is I would then go down to the origin or the pole, but I'm going to say origin because we all kind of know what that is. And then I simply want to go up 3 circles. So there's a circle, there's a circle, there's a circle, there's 3 circles, boom, done. That's it. So here for 4 comma 3 pi over 2, let's figure out where 3 pi over 2 is. There it is. Go back to the origin. And now I want to go 4 units of measure towards 3 pi over 2. So 1, 2, 3, 4. How about negative 2 comma 0? This is a good one. We have 0 radians. There's 0 radians. So I'm going to go back to the origin. But now instead of going towards 0 radians 2 spaces, I want to go away from 0 radians 2 spaces. So I'd go left 1, 2. Right here, negative 3 comma pi. Let's first locate pi. There's pi. Let's go back to the origin. Now we don't want to go towards pi 3 circles. We want to go away from it 3. So 1, 2, 3. Boom. And then I will do, let's go and skip down to example 9. We're starting with radians first. So negative pi over 3. Here's what I would do. I would first gain a level of awareness of, well, where's regular pi over 3? Here. That is a 60-degree rotation. So what we have to do is we have to do a negative 60-degree rotation, meaning we have to go this direction. This is where negative pi over 3 is. So from negative pi over 3, which is here, let's go back to the origin. And now we want to go away from that 1 circle. So away from it right there. Boom. And I'll do one more of those. How about this one? Let's do this one. So negative pi over 2, what I'm first going to do is show you where regular pi over 2 is. That's 90 degrees of rotation. We need to do negative 90 degrees of rotation. So from here to here, this is where negative pi over 2 is. Go back to the origin. And we don't want to go towards it 3 spaces. We want to go away from it 3 spaces. So 1, 2, 3. And hopefully that's enough to help you figure out the rest of that page. I would like to mention that on example 9, I think I accidentally said 30 degrees. It should be 60 degrees of rotation. So from here to here, 60 degrees. From here to here is negative 60 degrees or negative pi over 3. Okay, looking at 13 through 16, convert the following polar points to rectangular coordinates. Now for this section here, we will be using these formulas. In order to convert from polar to rectangular, those are the formulas you're going to use. And in my opinion, these are the easiest ones because the pattern is predictable. So we're going to do 5, that's our radius. In polar coordinates, the first number is your radius, and then this is your angle theta. So here's the pattern. It's going to be, you could just follow along the formula here, but in order to find x, we're going to do r, which in this case is 5, cosine, and then your angle, comma, 5, sine, angle. And then here's what I like to do because it helps me to not make a mistake. I'm doing 5 times parentheses, 5 times parentheses, because now what we have to do is we have to go to our unit circle and you have to find the cosine value of pi over 3. You're going to have to be able to fill out a blank unit circle on your own. Just a heads up. So the cosine value at pi over 3 is 1/2. And the sine value of pi over 3 is root 3 over 2. And then you just multiply. 5 times 1/2 is 5 over 2. And 5 times root 3 over 2 is just 5 root 3 over 2. And that is your answer right here. Okay, I'm going to go ahead and skip 14 and 15 so that you can try some of those on your own. An answer key is on my Canvas page. Let's do 16. Remember, this is a polar coordinate. So this is our radius. This is angle theta. So let's follow that pattern again. -1 times cosine of our angle, -pi/6, and then -1 times the sine value of -pi/6. So once again, I just like to do this because it prevents me from making a mistake. -1 times something, -1 times something. Now -pi/6. I'm going to give you a unit circle so that you can see this. Here's where regular pi/6 is. That's a rotation of 30 degrees from the positive x-axis. So if we're going to do -pi/6, we have to rotate -30 degrees, which is here. So this is our cosine and our sine values. We have a cosine value of √3/2 and a sine value of -1/2. So that's what I would substitute in parentheses. √3/2 and then -1/2. And then we multiply. Well, -1 times √3/2 is just -√3/2. -1 times -1/2 is +1/2. And there's your answer for 16. 17 through 20. If you're going to convert rectangular to polar, these are the formulas we're now going to use. That one and that one. That's what we're going to use now. I'm going to now shift this up. I'm running out of space. Okay, convert the following rectangular coordinates to polar points on 0, 2 pi and r is greater than 0. Try to disregard that. Just if you can solve these following the formula, you're going to be fine. So we're going to take 2, -2. Remember, those are x and y coordinates. We need to convert them to a radius and an angle. So let's start with radius. In that formula up here, in order to find radius, we have to do the square root of x squared plus y squared. So square root of our x value squared plus our y value squared. 4 plus 4 square root of 8. Quick math, what does that reduce to? 2√2. Winner, winner. Pollo dinner. Pollo is Spanish for chicken dinner. All right. So 2√2. We have now found our radius. Yes, question.
What if you counted wrong?
Okay, now let's find tangent. So that tangent right here, here's the formula for that. Inverse tangent of y over x. Try not to let that inverse tangent throw you off. I'm just going to write tangent, and I think you'll see why in just a moment. So our y value is -2. X value is 2. So we have tangent of -1. So what we're supposed to do now is we're supposed to figure out, well, where in our unit circle do we have a tangent value of -1? There's 2 places, here at 3 pi over 4 and here at 7 pi over 4. So we just need to find where in the unit circle we have a tangent value of -1. 3 pi over 4, 7 pi over 4. Only one of those is the right answer. Do you know which one it is? Thanks for playing. I'll give you a dum-dum later, but no, it's not that one. It's 7 pi over 4. Here's how you can tell which one. You go back to your rectangular coordinates. If you had to plot that on a coordinate plane, what quadrant would it fall in? It'd fall in quadrant 4 because right to down to quadrant 4. So therefore 7 pi over 4 is the answer. And that's why these are a little bit more difficult than doing the ones we just got finished doing a second ago, because there's just a little bit more to them. So anyway, here's your answer. 2√2, 7 pi over 4. There we go. All right, example 20. 2√2. That's our x, that's our y. We are converting to radius and an angle. Okay, so in order to find radius, remember that's the square root of your x value squared plus the square root of your y value squared. Okay, so these look a little bit more complicated than they are, so I'm going to slow down a little bit. -√2 squared. is the same thing as negative root 2 times negative root 2. Well, I think we're all aware of the fact that a negative times a negative is a positive. The square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. Good. Plus square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. So therefore, this simplifies to the square root of 4, and the square root of 4 is 2, comma. Now let's go find our angle. Tangent of y root 2 divided by x negative root 2. Is my final answer going to be positive or negative? Negative, good. And anything divided by itself is 1. So where in our, man, I wish it was something different from tangent of negative 1 again. We've already determined that we have a tangent value at 3 pi over 4 and 7 pi over 4, a tangent value that's negative 1, that is. Which one is it going to be this time? 3 pi over 4 this time. Great, because this, if we were to plot it, would be in quadrant 2. That is your answer for example 20. Okay, examples 21. We are converting the following equation to polar form. These are currently rectangular equations. We are going to convert them to polar. You see that y there? What I'm going to do is I'm going to go to my formula chart here. This one will be given to you on your test. And I'm going to find out which one of these formulas starts with y. Boom, that one. Y is the same thing as r sine theta. So rather than y equals 2, I'm going to do r sine theta equals 2. Now, most of the time when we have an equation in rectangular form, it's like y equals x or y equals x squared or whatever. In polar form, they're set equal to r. So we need to isolate r by dividing both sides by sine theta. So r equals 2 over sine theta. And does anybody remember what the reciprocal of sine is? Starts with a C.
Cosecant.
Cosecant. So there's another way of writing this. 2 times cosecant. Both of those are correct. Okay. Example 22. X equals negative 7. What I would do is I would go up to your formulas and find x. Boom! X is the same thing as r cosine theta. So I'm going to do some swapping. Instead of x, I'm going to do r cosine theta is equal to negative 7. Let's now isolate r by dividing both sides by cosine theta. Negative 7 over cosine theta. Does anybody remember what cosine's reciprocal is? Starts with an S. Secant. Secant theta. Both of those are correct. And now example 23. What I would do is I would go up to your formula chart and see if I have one that's x squared plus y squared. Where do we have x squared plus y squared? Boom, there it is. I see that is the exact same thing as r squared. So I'm going to convert that to r squared. R squared equals 16. We need to isolate r by taking the square root of both sides. R equals 4. That is your answer. 24. Here's what we need to remember. 2 times cosecant theta is the exact same thing as 2 over sine theta. We used reciprocal. Now, what we're going to want to do is multiply both sides by sine theta. That would give us r sine theta is equal to 2. And now we can go look at our little formula cheat sheet here. Careful with that word. R sine theta is equal to y, r sine theta. So this is the same thing as y equals 2, and that's your answer. Sorry, I forgot to mention what we were doing. Now we're going to convert these polar equations to rectangular. So we're just going the other way. Okay, example 25. There's two ways of solving this problem. I'm going to start by multiplying both sides by r. So if I multiplied r times r, that's r squared. If I multiply 2 times r, that is 2r. Okay, now, give me 1 second. Okay, actually, scratch that. That's not what we're going to want to do here. As I was working that out, I was like, I don't think that's going to work. Okay, let's do it the other way. Rather, let's look for in our formula sheet where we find r and what that's equal to. So r is the same thing as x squared, the square root of x squared plus y squared. So I'm going to substitute that. R, that's the same thing as the square root of x squared plus y squared. Set that equal to 2. Now, what we're going to want to do here is we want to get rid of the square root. So we would square both sides. That would leave us with x squared plus y squared is equal to 4. And now we have a rectangular equation for a circle. That would be your answer for that example. Okay, 26. If you see theta equals pi over 3, let's multiply both sides by tangent. Theta equals tangent of pi over 3. Okay, now tangent of theta, that is the exact same thing as y over x. And in our unit circle, tangent of pi over 3, that is root 3. So the tangent value at pi over 3 radians is the square root of 3. Multiply both sides by x. Y equals root 3x. And that would be your answer for that one. For example 27, for each of the following polar points, write, and then it has a lot of this stuff. Okay, here's pretty much what they're looking for. They have given us 3 comma pi over 2. I'm gonna copy that down again. 3 comma pi over 2. Remember the very first page we plotted the point 3 comma pi over 2? Well, there's actually 3 other ways of writing this, and it would equate to plotting the exact same point. Here's the pattern. Whatever the number is, you want 2 of those numbers to be positive and the other 2 to be negative. Just follow that pattern. I need 2 of them to be positive and the other 2 to be negative. Now, 3 pi over 2, or actually just pi over 2, okay? We already have our radius. We already have those. We just need another angles now. So one of our angles was pi over 2. We need to now go the opposite direction and get to pi over 2. So if we went from here to here, that's pi over 2. But if we went from here, we're going into negative rotation, and then stopped here, we are now at negative 3 pi over 2. So this one would be negative 3 pi over 2. Okay, now negative 3. Anytime we're now using the opposite number of what it gave us, we now want to use the opposite radian to help us with this problem. So from here all the way to here, well, that's just 3 pi over 2 radians. That's a rotation of 3 pi over 2. And now we want to get to this location, but go the opposite direction. That would be a rotation of negative pi over 2. Negative pi over 2. And those are your answers for that one. Okay, let's try, how about 2 comma pi over 6? So copy that down, 2 comma pi over 6. I'm going to need 3 more sets of parentheses. We want 2 of them to be positive, the others to be negative. So pi over 6, where'd my units work for? Is here. If I'm going to use the other positive 2 and still use pi over 6 as a reference point, I don't want to go pi over 6 radians. I now want to go the opposite way, which would be a rotation of negative 11 pi over 6 radians. Negative 11 pi over 6. Now, if I'm going to use the opposite radius that it gave us, so instead of 2, -2, I want to go to the opposite radian, which would be here, 7 pi over 6. So let's do one regular rotation. That would be 7 pi over 6. And then now one negative rotation here, which would be -5 pi over 6. And on to the next page. Okay, let's look at now this page. Let me show you what you will not receive on your next test. All this stuff in dark gray. That is not given to you. That is given, that is given, that is given, that is given, but none of this, which helps you identify all the characteristics and features of each and every one of these. If you memorize that portion, it should make graphing and identifying a little bit easier. And by a little bit, I mean a lot easier. Okay, so how about we start here? Cosine theta. This is a circle. One way that I can tell is there's only one number in the problem. And the number's invisible, but there's a 1 in front of cosine. So what that tells me is we're dealing with a circle. So I would look for all the circles on this graph. The length of the circle is going to be 1 from the radius. Since it is positive cosine, then we're going to be symmetrical on the x-axis. So it looks like it would be in. Okay, here we are now dealing with a rose. The reason why you can tell it's a rose is because there's a number in front of theta. Anything that has a number in front of theta is a rose. Now, this is a even numbered rose. So in order to figure out how many petals you have, you need to take whatever that value is and multiply it by 2. So I would then begin looking for which one of these graphs has only 4 petals. Each of those petals should be a length of 3. And now, since it is cosine, what that tells us is, well, here's another rule. Since it's cosine and the n value in front of theta is even, that means we're going to have a petal that is symmetrical on every single axis. So it would be, where are you? Okay, let's take a look at that. Y'all are saying K? Oh, it's E. It's E because those are the ones that are symmetrical on every single axis. So this one would be E. Okay, now this one here, we are dealing with a rose. There's a number in front of theta. This time it's odd. Anytime it's odd, that tells you how many petals we're going to have. So this one is going to have 5 petals. Since it is odd, since it is cosine, that means 1 and only 1 petal is going to be symmetrical on the x-axis. And in this case, since the number in front of cosine is positive, it'll be symmetrical on the positive x-axis. So I would be looking for 5 petal graphs. Here's one. One of the petals needs to be symmetrical on the x-axis, which it is. It needs to have a length of 3, which it is. We should have 1, 2, 3, 4. 4 other petals. So this one's H, most likely. Okay. Let's go here. This right here would be a limacon, where A is greater than B. A is 2, B is 1. So that's going to be the only type of graph that we have that does not touch the origin or the pole. I should say origin because everybody knows what that is. Since we are dealing with cosine, that means we're going to be symmetrical on the x-axis. And since the number in front of cosine is positive, that means we're going to be symmetrical on the positive x-axis. So let me start narrowing it down to which graphs do not go through the origin. Here's one. There's one. Are those the only 2? Looks like it. Well, this is the only one that is symmetrical over cosine. But let's do a little bit more. So if you add your A and B values together, we'd get 3. So that means from the origin, we should be moving 3 spaces towards the positive x-axis, which this one does. And then you want to do your A minus B value, which would be 1, meaning we should be moving 1 in the direction of the negative x-axis, which we are. So yeah, F. Okay, let's find something different.
So 1 equals 2 minus sine theta.
This one here?
So, keep going to the left.
This one here? Okay, this one, A is greater than B, so we're dealing, you know what you just identified? I think you just identified that one. A is greater than B. We are dealing with sine, so we should be symmetrical on the y-axis. The number in front is negative, so negative y-axis. This is fitting all this so far. If you add your A and your B values, we get 3. So should we be going from the origin 3 in the negative y-axis, which we do. And then the difference of A and B would be 1, meaning we should be going 1 away from the origin in the positive x-axis, which we are. So that was W. Just remember, if you remember those rules, it should make these a lot easier. Okay, I'm now going to do this one. We're dealing with the rows. You can tell because you have a number in front of theta. How many petals is it going to have? It's odd. How many petals? 7. If it's odd, that's exactly how many petals you're going to have. Now, so what I would do is I just begin looking for which one has 7 petals. That's what I would do first. Next, okay, this is where this one gets a little weird. We are going to be symmetrical on the y-axis, but if your number is odd, to find out which y-axis, you have to multiply it by pi over 2. 7 times pi over 2 is 7 pi over 2. 7 pi over 2 is on the negative y-axis. So you would be looking for the one that has 7 petals. One of them is symmetrical on the negative y-axis. It looks like S. Is it S? That's what it looks like to me. S. Okay, example 31. Identify the conic and write an equation for the conics below. Well, this right here is a hyperbola, you can tell. This one's a circle. And this one is a ellipse. Okay, hyperbola. Let's think. Well, this is opening horizontally. So we're going to start with x squared over something minus, hyperbolas will always have subtraction separating them, and then y squared over something. If it opens horizontally, it starts x squared. If it opens vertically, it starts y squared. Okay, now let's figure out our vertices. Since this is opening horizontally, these are our vertices. Looks like we have one at -2 and +2. So our A value is 2. Square it and put it underneath the x. Now to figure out our code, I just roughly guessed, like here to here. It looks like I just, oh, maybe that's what these represent. So 3. Okay, gotcha. So if this coordinate goes here, it looks a little mixed. Okay, so this coordinate goes here. So this should be -3, and that would be +3. I see what they're doing now. Good catch. So our A value is 3. Square it and put that underneath the x. Okay, so from here, now our covertices from here to here, 0, 2, that is a distance of 2. So our B value is 2. Square it, put it underneath the y, set it equal to 1, and that's your equation. Okay, for this circle, we have no vertical or horizontal shift, so it's simply going to be x squared plus y squared equals, notice your radius from here to here, it's 2, r equals 2. Square it and put it there. That is your equation. Now for the ellipse, this is going to start, notice that we're centered at the origin, so there's no horizontal or vertical shifts. Ellipses will always start x squared over something, y squared over something, equals. Okay, it looks like this is a vertical ellipse. We'd have to go up 3 spaces, down 3 spaces to get to our vertices. So our A value is 3. To get from our center to our co-vertice, we'd have to go right 2 and left 2. So our B value is 2. Now with ellipse, If this is vertical, then you need to take that A value, square it, and put it underneath Y. We associate Y with vertical and X with horizontal. So therefore, take your B value, square that, put it underneath X, set it equal to 1, and you're done. Identify the conic graph and list the characteristics below. Here we're dealing with a circle. One dead giveaway is, well, there's no fractions, and it's set equal to a perfect square. That's usually going to constitute a circle, which it will. Circle. Oh, and also it tells us R. I mean, a circle is going to have a radius. In order to find that, you're going to take the square root of that number, which would be 4. Center, take those two numbers and reverse the signs. So -4, comma, -2. And let's go ahead and graph. So left 4, 1, 2, 3, 4, down 2. There's our center. From the center, we now want to plot our radius. So we'd go up 4, left 4, down 4, 1, 2, 3, and right 4. There's our circle. So our domain from left to right would be -8, comma, 0. Our range from bottom to top would be -6, comma, 2. 35, we're dealing with a ellipse. One way you can tell, fraction form, and the biggest giveaway is the fact that it's a plus sign. I'm going to go ahead and plot the center. It doesn't tell us to list the center. I like having that information. Our center is going to be 1, comma, -3. So right 1, down 1, 2, 3. Let's see. Underneath the X, we have the biggest denominator, 25. So take the square root of that. That gives you your A value. Take the square root of the second denominator, since it's the smallest denominator, it's going to be help us with our B value. And this will now help us graph. So from the center, since this is going to be a horizontal ellipse, we want to go right 5, 1, 2, 3, 4, 5, and left 5. Those are our vertices. To do our co-vertices from the center, from the middle point, go up 2, down 2, graph. There's our major axis. There's our minor axis. Now just the easier stuff. So the length of the major, you could count from here to here, or you could just take your A value and multiply it by 2. Length of minor, you could count from here to here, or take your B value, multiply it by 2. Domain, all the X values from left to right. So it looks like -1, 2, -4, comma, 6. And range, all your Y values from bottom to top, looks like -5, comma, -1. Okay, so our vertices are going to be that and that as ordered pairs. So -1, -2, -3, -4, and then down 1, 2, 3. And then now that one, right 1, 2, 3, 4, 5, 6, and then down 3. So your co-vertices are going to be that and that as ordered pairs. So right 1, down 1. Then right 1, down 1, 2, 5. Okay, foci, that is going to be A squared minus B squared equals C squared. So A squared minus B squared equals C squared. 25 minus 4, 21. Square root. So the square root of 21 is equal to C. So, you know what? I'm going to be honest. That is, as far as plotting those ordered pairs, that is more trouble than it's worth. I would not worry about that. The main thing to take away is your C value. the distance from center to your foci is going to be square root of 21. That's the biggest thing. Try not to worry about the other. That is way too much. Example 36, we are dealing with a hyperbola. Main giveaway is we're separated by a minus sign. That's your big giveaway there. Center 0, 0. The first denominator will always help you with your vertices. You need the square root of that. So our a value is 3. The second denominator, if it's a hyperbole, will always help you with your covertices, and the square root of that is 4. Okay, so let's plot our vertices first. Notice it starts with y squared. So this is going to be a vertical hyperbola. So you're going to want to go from the origin or from the center up 3, down 3. And to plot your covertices, we're going to go right 4 and left 4. So vertices, negative 3, 0, 3, 0. To find your foci, it's going to be a squared plus b squared equals c squared. So our foci is 5. So we'd be at negative 5, 0. Oh my gosh, this is what I get for going too fast. I wrote my vertices in the wrong order. You should actually, because your vertices are going to be vertical on this in this case. So 0, negative 3. Sorry. Like I said, going fast and doing math usually does not work. Your foci is going to be, since this is a vertical ellipse, they're also going to be vertical. So 0, negative 5, and 0, 5. Okay, asymptotes. Draw your rectangle. To find your asymptotes, if you're able to draw your rectangle, one of the easiest ways to do it is use rise over run. We're going to start at the midpoint and work your way over to the corner of the rectangle. So up 3, right 1, 2, 3, 4. So y equals plus or minus 3 over 4x. Now I'm going to draw my asymptotes from corner to corner of the rectangle and then corner to corner the other way. And then just remind yourself that this is a vertical ellipse, so we need to follow along the asymptote this way, begin to curve as you approach the rectangle, go through the vertice, and then go the other direction. So that's what a hyperbola would look like. Domain on vertical asymptotes is going to be all real numbers. That's how we write it in interval notations. And your range is going to be from negative infinity to the first vertice, negative 3. And then it will resume at 3 and continue on to positive infinity.